let us discuss what is network layers. So, dear students, in the virtual area network, what is configuration? Right. What is configuration? Then there are three ways of configuration. You should understand that, and also how to create communication between switches using virtual area network, that is stable maintenance, frame tagging, time division. Under time division, IEEE standard will come. And what are the advantages of virtual area network? So cost reduction, creating virtual work groups, and security. These are the important concept in the virtual area network. So if we get the questions, what is virtual area network? Describe it. And what are the advantages of virtual area network for 6 months or 8 months? You should know it. Now, let us discuss what is network layers. So network layer, as we know that, so this is fourth layer from the uh, open source interface in OSI. Network layer is fourth layer. First one is application layer, second one is physical layer, session layer, and network layer. Right? APSTN, sorry, fifth layer. Application layer, physical layer, session layer, transport layer, and network layer is the fifth layer. So what is that network layer? Let us discuss. So in the network layer, TCP IP protocol should be there, right? So network layer is also a physical layer, like means physical, so network layer means some physical setup should be there. So that's why TCP IP protocol should is responsible for the host to host delivery of datagrams. Datagrams is nothing but different format of information or messages. It provides services to the transport layer and receives services from data link layer, right? So network layer can provide services to the transport layer and receives services from data link layer, right? So what are the services of the network layer? Let us discuss. The internet layer is a group of internetworking methods, protocols, and specifications in the internet protocol suite that are used to transport network packets, right? Of course, from the organizing host across network boundaries, right? So it provides the services that internetworking. So how to connect number of, for example, in the digital signal processing lab in last semester, you might be seeing that using a single server, there are 24 systems have been connected. So like that, so using server, we can send the information, means we can control and they send the information from a single server to the number of clients, means number of host or computer systems, though it will be provided by the network layer. That is also one of the important service of the network layer. Next is the internet layer derives its name from its function facilitating the internet working, which is the concept of connecting multiple networks with each other through gateways. Of course, using gateways also we can connect any number of computer systems using a single server, using a gate. That is also one important network layer service. So network layer service is how to connect group of computer systems, and using a gateways how to connect number of computer system using multiple networks. So these are the services of the network layers. So in network layers, what is packetizing? So packet is nothing but the standard format of the information or data in the network. So IP packet, internet protocol packet, for example. Now let us see what is packet or packetizing. The network layer is definitely packetizing, means in the network layer packet format should be there. So encapsulating the payload or data received from upper layer. Upper layer is the data layer, data link layer, right? Lower layer of the network layer is transport layer, upper layer is data link layer. So network layer should provide the services to the data link layer, means packet concept, packet standard packet format should be available in the network layer. That is called as network layer packet at the source. The network layer is doing the services of a courier such as the postal office, which is responsible for delivering packages from a sender to receiver without changing or using the contents, right? Packet should have the standard format of the data, and to which destination, means to which system it has to deliver the data. So packet should have that standard address. Here postal office is nothing but destination address to which system that packet has to be delivered, and which in what information, what is the content of, what is the content of packet should be delivered to the destination. So these are the content of packet. So the packet content should be the destination address, means to which computers or destination the data has to be delivered, and which data, what type of data or which data has to be delivered. That are the contents of packetizing. The source host receives the payload. Payload is nothing but information from an upper layer protocols, adds to a header that contains the source and destination address and some other information. As I told you, packet contents are both source and destination address with information required by the network layer protocol, and delivers the packet to the data link layer. The source is not allowed to change the content of the payload unless it is too large for delivery and needs to be fragmented. For example, you assume that the packet size is 32-bit. 32. If the information content is also 32-bit, then the source address, that means the source will no need to be change that format. Only 32-bit information is enough. For example, if the information size is 64, then that 64 should be divided into equal size, that is 32 to 32-bit information. That is called as fragmentation, right? So fragmentation means how to divide large number of data into equal number of data size. That is called as a fragmented. So understood. Again, the network layer, let us discuss what is routing and forwarding. Right? Packet understood now, dear students. So packet means packet contains a source and destination address and information. If the packet size is larger, then equally in the network layer, software will divide large number of data into equal number of whatever the specifications of packet size. Now let us discuss what is routing and forwarding. Dear students, in previous classes we have discussed routing means how to transfer the data from source to destination with mediator, means intermediate computer system. That is called as a routing. So routing is a path. Please understand that routing is nothing but communication path from source to destination using intermediate computer system, right? For example, if you want to send any message from Bangalore to Mysore, right? Then routing concept can create a communication path from Bangalore to Mysore using different districts like Ramnagar district, Mandya district, and different district. So different districts will be acted as a number of intermediate nodes. Then what is the shortest path to travel from Bangalore to Mysore? Right, that is called as a routing. So routing is nothing but communication path, shortest communication path from source to destination. Right. Next one is forwarding. What is the meaning of forwarding? Forwarding is nothing but how to send the data from Bangalore to Mysore. For example, assume that Bangalore is a source node, Mysore is the receiver node. So how to forward the data directly, because distance is more from Bangalore to Mysore, distance is more, right? So in networking, minimum distance is there. If the minimum distance is there between source and destination, then easily without need help of intermediate nodes, we can transmit the data from source to destination. If the distance is more, for example, from Bangalore to Mysore, then we need the help of intermediate district like Mandya Ramnagar and all like that. So Mandya district, Mysore, Ramnagar district or Chanpatna. So these district will be acted as intermediate node. So using these intermediate nodes, we will forward the data, means source will forward the data to the destination. So that is called as a forwarding. Now let us discuss in detail. The other duty of network layer is important as the first, the routing and forwarding concept should be important directly. As I told you, if the distance is less according to network specification, directly we can create the routing path and forward the data. If the distance is more, so then only forwarding concept is required. Right, that's why now let us discuss what is routing. As I told you, the network layer is responsible for creating routing packet from its source to the destination. So routing concept, how to create the communication path from source to destination. A physical network is a combination of network layers of both local area networks and wide area networks and routers that connect them. So routers can connect both local area network as well as wide area network. This means that there is more than one route from the source to destination. As I told you, to travel from Bangalore to Mysore, so different intermediate nodes are required. So that's why there is more than one route from the source to the destination. From Bangalore to Ramnagar one route, from Ramnagar to Mandya one route, from Mandya to Mysore another route. Routing system, that is called as a multiple directly, because distance is more. We cannot travel directly from Bangalore to Mysore. Through different districts we can travel. That is called as routing. The network layer is responsible for finding the best one among these possible, right? The network layer, the network layer responsibility, and also the network layer responsibility needs to have some specific strategies for defining the best route. As I told you, shortest path, which is the best path in the network, because n number of paths will be there to travel from source to destination. Then network layer using spanning tree or shortest path algorithm, it will discover or find that which is the shortest path. That is the main responsible of the network layer in the internet today. It has to be done by running some routing protocols to help the routers coordinators their knowledge about the neighborhood and to come up with consistent tables to be used when a packet arrives. Right there in network layer, there should be some standard protocol to create the routing. Right, for example, as I told you, TCP/IP protocol and UDP protocol, internet protocol, there are so many standard protocols are there for creating the means for routing concept. Right, routing. Now let us see what is forwarding. So in simple way I will tell you, forwarding means how to send the data or packet from source to destination using intermediate nodes. That is called as a forwarding. If routing is applying strategies and running some routing protocols to create decision making tables for each router, forwarding can be defined as the action apply each router when a packet arrives at one of its interface. Once the packet will send from source to will transfer from source, then forwarding concept should be there. The decision making, of course, decision here making means through which path packet has to be forwarded. So that is called as decision making. And every time to which, for example, intermediate node, to which node the data has means packet has transmitted. So every time the decision making table has to be updating. That is called as forwarding table, and sometimes that is called as a routing table also. Of course, once the routing concept has been created, then routing table is nothing but forwarding table, or normally that networking table we can say. When a router receives a packet from one of its attached network, it needs to forward the data packet to another attached network in unicasting or multicasting also there in the forwarding. Using unicast or multicast, forwarding concept will be there. To make this decision, the router uses piece of information in the packet header. So in the header, that forwarding networking concept should be there, which can be the destination address to find the corresponding output interface number in the forwarding. Of course, in the forwarding technique, so to which destination the packet has to be delivered should be available. That is called as a destination address in the header, packet header. Now, what are the other services of the network layer? Let us discuss. Error control, right? So, error control means, for example, error control is nothing. Let us say what is network error. So, network error means, for example, because of poor signal strength, because of poor signal strength, if the source is not able to transmit the data to the destination, then definitely destination is not able to receive the data from the source. That is also one type of error. For example, in local area network, physical connection using cable only we can establish the communication. For example, in case if any cable is disconnected, if any physical cable is disconnected, then how to transmit the data? So that is also one type of error, right? So in network layer, how to control that errors or corruptions in the network? Let us see. So the designers of the network layer added checksum here is nothing but error. What type of error will occur in the network? That is called as a checksum field to the datagram to control any corruption in the header, but not in the whole datagram. Only it is available in the header of the packet, not in the information. Datagram is nothing but information, right? So datagram, we have seen that virtual. In the next section also we will see. This checksum may prevent any changes or corruption in the header of the datagram, right? As I told you, how to increase the signal strength, then how to maintain the continuity of the connection of the cable. That is called as error control or prevention, right? The network layer in the internet does not directly provide error control. Of course, it directly network layer cannot provide error control. The internet uses an auxiliary protocol, means using some standard protocol like auxiliary protocol and ICMP, internet control message protocol. Dear students, ICMP here I have mentioned. ICMP is nothing but internet control message protocol that provides some kind of error control if the datagram is discarded or as some unknown information in the header. If data is not delivered to the destination, then using auxiliary protocol or internet control message protocol, internet layer service can provide prevention, right? It avoids error in the internet. So that is called as a error control. So next one is flow control. What is flow control? Flow control, dear students, please in simple way I will make you to understand. Flow control is nothing but, let us see what is flow. Flow means how to send the data from source to destination through intermediate nodes, right? So from source to one computer system, another computer, until it will reach to the destination, right? That is called as a data flow or packet flow. Understood, right? How to send the data. Sometimes that data, whatever the data we will send to the destination from source, may be missing or may be lost. That is called as flow control. How to avoid that loss of data, right? Missing of data, that is called as flow control. So flow control regulates the amount of data or a source can send without overwhelming the receiver. If the upper layer means data layer, source computer produces data transfer, then upper layer at the destination computer can consume it, right? Then to control the flow of data, right, the receiver needs to send some feedback to the sender to information the later that it is overwhelmed with data. For example, dear students, flow control, as I told you, one way is how to avoid that loss of data or loss of packet. Another example, for example, if a source wants to send 2 data packets, 3 or any number of data packets, their priority should be given. Which data packet source wants to send first, next second which data packet, third time which data packet. So that is called as overwhelmed with data, right? At a time n number of data source cannot send. One by one data has to be sent and other data packet will be in queue. That is called as flow control. Right now, the network layer in the internet, however, does not directly provide any flow control. Like error control also, network layer cannot provide any flow control. There are some standard protocol like in error control we have seen auxiliary protocol, internet control, message protocol, like that. The datagrams are sent by the sender when they are ready without any attention to the readiness of the receiver, right? That is called as flow control. Error control we have discussed, flow control we have discussed. Now let us discuss what is congestion control. Congestion is nothing but when a source wants to send n number of data packets, that is also congestion. And also in a switch, in a single switch, if there are n number of virtual local area network, so there will also be some error will be there. That is called as a congestion control. In network layer, when the message traffic is heavy, as I told you, in the traffic we might be observed that in a traffic there are because of n number of vehicles, definitely traffic is heavy. So that is the meaning in congestion control. Congestion control is nothing but in a single network, if there are n number of data packets, definitely message traffic is heavy, so it slows down the network response time. Of course, definitely in a single network, for example, if you want to travel from Hebbal to our SVCE college, if there are more heavy vehicles, definitely we will take, right, more number of time, isn't it? More number of time. It means the response is low. Right? So means performance or response is slow. So that is called as a congestion control. In the same example, if there is no any, if there is less vehicles, so definitely we can move fastly. We can reach our college fastly. Then response is high. Effect of congestion: as delay increases, performance decreases. Of course, if congestion is increases, means if delay increases, definitely the performance of the network will be decreased. Then if delay increases, retransmission occurs, making situation worse, right? Fourth important is quality of services, right? So in the network layer, quality of service is also very important. So how to provide good quality of services? Good quality of services with respect to, right, bandwidth is also one important concept of the quality of services. Then good security system is also quality of services. So now what is quality of services? Is a set of technologies that work on a network to guarantee its ability to dependably run high priority applications and traffic under limited network capacity. Right, measurements of concern to quality of services, as I told you, bandwidth is nothing but throughput, latency is nothing but delay, jitter, variance in the latency, and error rate. So these are the important concept of the quality of services: bandwidth, delay, and variance, and error rate. So these are the important quality of services in the networking for the with respect to good performance of the network. So good bandwidth should be there and less delay should be there, and the jitter should also be good, and error rate should be minimum. So then only network layer can provide good quality of services.